Okay. Now I'm starting to get nervous because I know it's going to get really hard and then I'm just going to be struggling and it's going to be really awkward. Oh yeah, I remember these. These are cool. Now we have some stuff. Let's see. Yes. Yep. So, here we have 0 through 14. Let's look at this example. If we copy from 12, that gives us an 8. And if we copy from bracket 12, what is that giving us? Imagine each thing in the inbox is an address with 0 to 9. For each address in the inbox, pick up the letter at that address and outbox it. So we are going, let's see. I grabbed, just a second, I'm trying to grok this. What can we access? Copy from, what does that do? Bad tile address. You can't indirect to a tile with the letter like N. Only numbers allowed. Okay. So if I do that, that's going to give me address 8. Okay. Okay. So here are numbers down here. And we use those to reference these addresses here. So each thing in the inbox is an address. So we need first the item at address 1. We're going to copy, well, first we have to store this somewhere so we can reference it somewhere in time. So then we're going to grab whatever's referenced at 10, that index number. So that's going to give us 1, because we put 1 in 10, and then we're going to access item number 1. I know that sounds very, very confusing, but see, we put 1 there, and then she grabs the item at position 1. Okay, so then we just outbox that and continue. So maybe if you watch this, maybe it will make more sense. So L, the item at position 6, then the item at position 1, and then the item at position 1 again, and the item at position 8. And now things are going to get more tricky. String storage floor. Oh, now we have some null terminated strings. Okay, so in languages like C, again, I've mentioned this before, you have to allocate memory for what you're going to store in the computer. So if you're doing letters, you don't necessarily know how many letters you're going to need in like a sentence, so you try to overestimate that. But let's say your sentence is hello world, and then you had more memory. You don't want to keep reading after hello world. That's just going to be a bunch of garbage data. So that's why we use null terminators in C to denote hello world, null terminator. Okay, don't read anything after this. So we're essentially doing that here. We're going to read for each address provided in the inbox, read everything and then following. So we get 4, oops, 4, and then we keep moving forward until we get to the null terminator, so TH would go out first. Then 15, we do E, and then null terminator. So, let's say get, it's so hard to write with this, get first letter, address, L T R A D D R. So the address of the first letter. Grabbing that. We are going to also put that address here. So this is our current address, because we want to keep grabbing everything after that. So we're going to grab that first letter that's referenced at our address, put it in the outbox, then increment our address to get the next item in memory, copy from that address. If it's 0, we're done with our string. Otherwise, we're going to keep outboxing it. So we don't want to output the 0. We're just start over. At this point, if it's not 0, we grab that letter, we outbox it, and we're going to keep looping. We're going to bump up that address number, grab it, and, process it. So, let's see. 4. Grab the T, that goes out. What's the next one? 5, what's at 5? H. Throw that one out. Bump it up, what's at position 6? It's a 0. Well, we're done with that one. And so on. Here's 15. Grab the E, then we got a null. What's at address 7? We have T. Then we need address 8. That's an A. Then we need address 9, that's an R, and then the next one's the null terminator. So, we'll just let that run. XXX. Oh look, mine was actually not that inefficient. Okay. String reverse. Now we get to reverse our strings. Ole. Yadot o woi ero wo. Aha. Okay, for each 0 terminated string, reverse it and put the result in the outbox. Alright, so how are we going to do this? Well, we should have plenty of memory blocks to store a word. We're going to assume we are not getting any words of size 14. Oops. So let's just copy everything from the inbox. Let me think real quick. So this is at it's a 0. Let's say, we'll put the address here. We're gonna grab the first thing. Okay, wait, no, let's initialize. We're always going to want to start the string we're reading at position 0. So we're gonna put 0 in the address. We're gonna do F at 0, A at 1, L at 2, and so on. So then we'll grab from the inbox. That's going to be copied to wherever this address is currently pointing. And we'll bump this up so we go to the next spot, number 1, number 2, number 3. And we'll keep repeating this. But we also need to check for the null terminator. So, let's see. Inbox, if we get a null, so this is, let's put this as read the string. So we basically have 2 little algorithms in here. Read in the string. Let's just make sure this works as I hope. So F goes there. Grab A goes there. L goes there. And And then once we get a 0, we're going to need to handle that. So, this is going to be 0, 1, 2, 3, 4. Now we want to reverse. So we're basically taking each item and going to output it. So copy from whatever that address is, output it, bump down the address. The address is now, well, we'll stop it if it's negative. If it's negative, we're done with the process and we're going to start over. Okay, so grab the previous thing, copy from the address outbox, then bump again. We need that. Let's see if that logic works. So, okay, we got that whole word. That's a 0. We're gonna bump that down. We need number 3. Grab that, throw it there. What's the next letter at number 2? Put that there. Next letter at number 1. Grab A, put that out. And number 0, grab M, and then let's make sure this works as intended. So it's negative, we're gonna reinitialize and start all over. Mini false win. Okay. Yay. Also, I want to point something out if it will let me show this. Nope. Okay. I'm gonna try to stop this really quick once it's... I think this is the same text as before, which is good. So we have false, and then I'm gonna load in the win. Okay. Okay, this is what I want to point out. Notice that we have win and this E again. This is basically what happens in memory when you have a garbage value at the end after your null terminating character. That's why you don't want to read this whole string. We had a null terminator, so we know to end at number 3. We know not to keep reading and then have win with an E at the end. So, just a note. Ooh, okay. Inventory report. Accounting verification, surprise audit. Those are a few of my favorite things. For each thing in the inbox, send to the outbox the total number of matching items on the floor. Ooh, okay. So, we'll have to count the number of A's, of C's, of X's, and B's. We have a nice 0 given to us. We're gonna just keep that at 0 for reference, because we're gonna want to start our counter at 0 every time. So we're going to initialize. Let's take the 0 and put it here, make this our counter. Okay, so that's our initializing. Get letter, I guess. So we're gonna grab our first thing. How can we subtract like A and B? I assume we can. Let's just go ahead and try that real quick. Let's just do that up here just to test. Grab an A, we're subtracting B. It gives us a -1. What is C minus B? It gives us +1. Okay, so it's like string compare in C, which, let me open the desktop capture and we'll look at this real quick. So, if we're comparing two strings, A and B, it's going to return either generally -1, 0, or +1. So if they're the same, it's going to be 0. If the first character is lower, it'll be -1. So think of it like A comes before B, so it's -1 from B. And then, let's say, C comes after B, so it's +1 after B. But I don't know for sure if I mean, I guess It says less than 0 and greater than 0 because you can't say exactly what that value is going to be, but generally it seems to be -1 and +1. So, hey, yeah, that's how that works. Back to the game. Oh no, my window is small. What happened? Oh, did I resize it? Dang, I'm sorry if you had to watch a small window this time. We're gonna center that back on the screen. Okay. So we're gonna grab each letter. We're gonna grab that letter and let's just put it here. That's where we're storing the letter. Then we have to iterate through all of these until we get to 0 and see if we have a match. So, grabbing, let's say, compare. Let's grab from the letter, subtract whatever is at this counter. Oh, we also need a sum because we're counting. Oh, wait. Yes, the total number. So, let's just say, yeah, total. Okay, we need to update something. Copy 0, copy to the total as well. So, copy from our letter, like B. Subtract from whatever this first item is. If it's 0, then we're going to bump up the total. If it's not, we're going to just keep moving on. So, match. Then, either way, we need to bump up the counter to get the next memory address. And we're going to do that again. Copy from letter, subtract whatever's at that counter. Now we also need to check for 0. So, jump. Let's say, just check for the terminator. Copy from whatever's at that address. If it is 0, we're done. Next letter. Jump back to the beginning. Okay, we'll see how this works. We gotta be. Wait, you didn't initialize my shit. Oh, that was my test. Oops. Oops. Okay. Oops. Copy, initialize those. We need to, grab from the inbox and copy it to the letter. And then compare. Okay. Hey. Counter's at 0. Total's at 0. Grab the B. We're going to compare this B with that. That's a 0. Counter goes up. Oops, I need to grab the B. That did not work. Okay. So the counter goes up. I need to copy from the letter. And, I do not have that loop going right. Loopy. Bump the counter. Check if it's 0. If it's not 0, we... Wait. Okay, I might have to double check this and step through. Counter 1, grab A. Oop, go back. Oh wait, she did subtract it, okay. Yes, okay. Maybe I'm not mistaken. Grab the X. I have just that extra step, I guess. So we have one extra. Compare with B. Compare with C. Compare with that one. That should match. That extra step is bugging me, but I'm not going to bother with it right now. So we should have an extra 3. And then it should end at this terminator. 14. Grab 0. Oops. I did not output the total. So, if it's 0, we need to grab the total and output that total, and then we can continue. So, I think this is okay now. We did it! Oh no! Well, you know, I had that extra step in there. Let's watch this! I cannot imagine being somewhere for 33 years. I am not even 33 yet.
Hey, where's Carol?
Oh no!
Oh my god! This coffee is amazing.
Well, office coffee is never amazing.
Back to work, ladies.
Office coffee is the worst. Like, diner coffee is good in a bad way, in that you're at a diner, so you might as well drink the coffee.
Everything equals 100% fine, whether within pleasant tolerance parameters or human skin layer. You're all going to be fine.
Sounds good. Yep. Okie dokie. Well, we're getting close to the end. This is kind of a deja vu. I think this is kind of where my brain stopped working around here. And also similarly for the sequel, something billion humans. What is it? 7 billion humans. I also got right towards the end, and then I had to grade final exams or something, and then I just forgot everything. Okay, well, next time we might try to finish this up, or maybe in a few episodes if I end up being really slow. So far it's been going pretty good. I'm actually going to record the next episode right now because I feel like if I step away, my brain's going to stop working. Yeah, so I want to not embarrass myself. But I hope you enjoyed. Thanks for watching. I'll see you next time.